Eunice, previously we have discussed the measures of central tendency. Now let's review what these three different measures of central tendency are.
They are the mean, median, and mode.
Here is a set of ungrouped data. These are the test results of 10 students. Let's use them for our revision. If I say that the students scored 65 marks on average, they did pretty well.
Just now, you used the mean to comment on the performance of the 10 students.
If I say among these 10 students, half of them scored 69 marks or above, they did pretty well.
In this case, you used the median to comment on the performance of the 10 students.
If I say among these 10 students, 3 of them scored 80 marks, they did pretty well.
Here, you use the mode to comment on the performance of the 10 students.
Eunice, can you elaborate more on the relative merits of different measures of central tendency for a given situation?
The mean is the most commonly used measure of central tendency. In our daily life, for example, we share the bill for a meal at the restaurant. The amount we each pay is the mean. Moreover, under normal circumstances, the mean can be used to find the sum of the data or even the value of an individual datum. Let's look at this example. Here's a set of 5 positive integers. The mean and the median are 6, and the mode is 9. You are required to find the values of these 5 numbers. The numbers arranged in ascending order are x, y, 6, 9, and 9. So the sum of these 5 numbers is 30. X and Y could be 2 and 4, or 1 and 5. When calculating the mean of a dataset, all items are considered. However, when there are extreme values in a dataset, the mean inclines to the side where extreme values are. In this case, it is not suitable to use the mean to reflect central tendency of a dataset.
So instead of the mean, what average is most suitable to reflect the central tendency of a set of data with extreme values?
The median. The median monthly salary of employees in a company and the median income of families in Hong Kong are examples. Usually, there are extreme values in family income, wages, and rent. The mean is placed near the side of the extreme values, so people may be misled when it is used to reflect the central tendency of the dataset with extreme values. There are 6 items in this dataset. The extreme small value 0 makes the mean less than the value of the majority of the items. Therefore, the mean is not an appropriate average, nor is the mode of 13, because it is the largest value in the dataset. The most suitable average for this dataset is the median.
In what situation is the mode or modal class the most appropriate average?
The mode or modal class is used when we want to use one of the items in the dataset as a measure of central tendency. For example, in the sales of shoes of different sizes in a shop. Only the mode which reflects the size of the highest demand is useful for reference.
Here is the information showing the distribution of blood types among some people. Which average is the most suitable for measuring the central tendency of this dataset?
Of course, mode is the answer. In this situation, the information that we need is which blood type is the most common. It doesn't make sense if we use mean or median to represent the central tendency in this situation.
We have elaborated on the particular situations in which the mean, median, or mode is most suitable to represent the central tendency of a set of data. Let's summarize their use.
Okay. The mean is affected by extreme values and it is unique. All data are taken into consideration in calculating the mean. The median is unique. And the mode must be one of the values in the dataset. It may not exist. It can also be found by observation. Johnny, While we are on the subject of measures of central tendency, will there be any changes in the mean, median, and mode when there are changes in a set of data?
Of course there will be changes.
If there are changes in a set of data, what would be the differences between the new mean, median, mode, and the original averages? Also, is there a general method that we can use to effectively find the values of the new mean, median, and mode?
Let's make some changes to a set of data and see whether we can draw a conclusion. There are 7 items in dataset A. The mean is 6, the median is 5, and the mode is 5 as well. These 7 items look like this when plotted on a number line. If 5 is added to each datum in set A, the new mean becomes 11, the median becomes 10, and the mode becomes 10. These new items look like this when plotted on a number line. The shape of the distribution of the new items on the number line is the same as that of the original items. It has only shifted to the right by 5 units. It is because 5 was added to each item. Eunice, can you see the relationship between the new mean, median, mode, and the original averages?
By simple deduction, we can infer that for a set of data, if a constant k is added to each datum, then the value of k is added to the mean, median, and mode respectively.
Then what will be the effect on these 3 averages if each datum is multiplied by a constant k? If each item is multiplied by 5, the result is like this. Due to the changes made to the items, the new mean is 30, the new median is 25, and the new mode is also 25. The new items look like this when plotted on a number line. What are the relationships between the mean, median, mode, and the original averages now that each item has been multiplied by 5?
By simple deduction, we can observe that for a set of data, if each datum is multiplied by constant k, then the mean, median, and mode will also be multiplied by k, respectively.
Such changes really do occur in daily life. Here are some examples.
Like when the teacher reminds students that their age will increase by 1 in the coming year. A constant is added to each datum in this case. So the averages will also be increased by this constant.
Likewise, for a team of staff with the same percentage increase in salaries, each datum is multiplied by a constant. So the averages will also be multiplied by this constant.
Johnny, are there any other situations where changing data will lead to changes in mean, median, and mode?
Of course. Let's discuss this further. If we delete a datum from a set of data, what will be the effects on these 3 averages?
The effects on the mean, median, and mode will depend on the nature and position of this datum.
Yes. Let's first consider the effect on the mean when the deleted datum is smaller than the mean. The mean of this dataset is 6. If 2 is deleted, there are only 6 items left in the set of data. 2 is smaller than the mean. The new mean is 6.67. The new median is 6.5, and the new mode is 5. The second situation is when the deleted datum is greater than the mean. For this set of data, the mean is 6. If 10 is deleted, there are only 6 items left in this set of data. 10 is greater than the mean. The new mean is 5.33, the new median is 5, and the new mode is 5. The conclusion is, when a datum is deleted from a set of data, if this datum is smaller than the mean, the new mean will increase. On the other hand, if this datum is greater than the mean, the new mean will decrease. What about the effect on the median if a datum is deleted?
First, let's look at the effect on the median when the deleted datum is smaller than the median. For this data set, the median is 32. If 24 is deleted, there are only 9 items left in this set of data. 24 is smaller than the median. The new mean is 32.89. The new median is still 32, and the new mode is also still 32. When the deleted datum is greater than the median. Using the same set of data, the median is 32. If 44 is deleted, there are only 9 items left in this set of data. 44 is greater than the median. The new mean is 30.67. The new median is still 32, and the new mode is also still 32. It seems that there is no effect on the median when a datum is deleted.
Of course not. There was no effect on the median in your particular example just now. However, this does not apply to other situations. Let's use the following set of data and investigate the effect on the median when a datum is deleted. In this set of data, if 3 is deleted, the median is 6.5. If 9 is deleted, the median is 4. What is your conclusion on the effect on the median after observing these examples of deleting a datum from a set of data?
When a datum is deleted from a set of data, if the datum is smaller than the median, the new median will increase or remain unchanged. On the other hand, if the datum is greater than the median, the new median will decrease or remain unchanged. Also, if the deleted datum is not the mode, then the new mode will not be affected.
Eunice, can you share with us what happens to the mean, median, and mode if an item is added to a set of data?
Suppose 4 is added to the data set. There are now 8 items in the data set. 4 is smaller than the mean. The new mean becomes 5.75. The new median is 5, and the new mode is also 5. In this situation, 14 is added. 14 is greater than the mean. The new mean is 7. The new median is 6.5, and the new mode is 5. The conclusion is, when an item is added to a data set, if the added data is smaller than the mean, the new mean will decrease. On the other hand, if the added data is greater than the mean, the new mean will increase. Let's discuss the effect on the median. When an item is added to a data set, if the added data is smaller than the median, the new median will decrease or remain unchanged. On the other hand, if the added data is greater than the median, the new median will increase or remain unchanged. Also, if the added item is the mode of the dataset will not be affected.
What about adding 0 to the dataset?
Let's observe the effect on central tendency if we add 0 to the dataset. Let's first discuss an example for a set containing solely positive integers. 0 is smaller than the mean, and there are 8 items in this dataset. The new mean becomes 5.25. The median is 5, and the mode is also 5. You can see that if a 0 is added to a set of data with all positive values, the new mean will decrease. The new median will decrease or remain unchanged, and the new mode will remain unchanged. Now, let's discuss this example with a set containing solely negative integers. 0 is larger than the mean. There are 8 items in this data set. The new mean becomes minus 5.25. The median is minus 5, and the mode is also minus 5. You can see that if 0 is added to a set of data with all negative values, the new mean will increase. The new median will increase or remain unchanged, and the new mode will also remain unchanged.
We have used examples of sets containing solely positive integers or negative integers for discussion. What will be the effect on the measures of central tendency if a set of data includes positive integers, negative integers, and 0?
That is what I want you to explore. If you can use the right examples, list the correct expressions, then you will come to a logical conclusion.